Hello, good evening, everybody. Welcome. It is 6 o'clock, so we are going to go ahead and get this webinar rolling. I'd like to welcome you to the Homeowner Association webinar series hosted by the Regional Stormwater Collaborative of Southwest Ohio and Northern Kentucky. The Regional Stormwater Collaborative is composed of stormwater districts, municipalities, and soil and water conservation districts in Southwest Ohio and Northern Kentucky. The purpose of the collaborative is to raise awareness about water quality issues in the Ohio River Valley. So during this webinar, we will discuss detention and retention basin maintenance and retrofits. I do just have a few housekeeping reminders. If you have questions for the presenters, please use the Q&A feature, type your question in, and we will be monitoring those questions, and we'll ask those questions to the presenters at the end of the webinar. We will be picking one door prize winner towards the end of the session. You must be present to win. We will call out a random name from the participant list, and then we will contact you using the email that you used to log in this evening. Presenter contact information and webinar recordings will be available on the Save Local Waters website, savelocalwaters.org/HOA, 1 week after the webinar. So I would like to go ahead and introduce Che Alberto and Adam Lehman from the Hamilton County Soil and Water Conservation District, as well as Ben Poole from Hamilton County Planning and Development. Take it away, gentlemen.
Yes, hi, good evening, everybody, and thank you, Sarah, for that nice introduction. My name is Che Alberto. I'm with Hamilton County Soil and Water Conservation District, and welcome to tonight's presentation. I'm glad you are all here instead of being outside with the weather still being pretty nice. So, I'd like to share this picture. This was taken, when I'm still going out in the field, inspecting construction sites. Contrary to a lot of what people say, streams in Hamilton County don't always run dirty during rain events. As you can see, this picture pretty much illustrates that. And the reason I would like to share this picture is that that muddy water coming through the side is from a construction site. And I know the topic of the presentation is detention basin maintenance and retrofits, but I just want to take you to detail what our involvement is on how these structures evolved. So with that picture, it illustrates the sediment discharge into the streams. And sediment is the #1 cause of biological impairment of streams in Ohio. And with these pictures, as you can see, on the left is a picture of the stream bottom, and on the right shows you a degraded stream bottom with the loss of habitat and reduced visibility. And according to the EPA, sediment is one of the reasons for the non-attainment of aquatic use in streams. So with that said, what we do with sediment with basins, these structures start out during constructions. We use these as sediment basins. And the reason for that is that the Ohio EPA mandates that the sediment settling ponds are required where stormwater collects or concentrates during construction. So what we do is we retrofit these detention basins with a slow release device called a skimmer that is to regulate the discharge of muddy water that's run off from the construction sites, and it's supposed to hold it and draw it down and hold it there and draw it down with a minimum of 48 hours. And these skimmers and sediment basins must be installed and functioning within 7 days of grubbing on a construction site. I just want to illustrate a couple of pictures of a working sediment basin. That pipe sticking out is the slow release device that controls the discharge of water from the basin. So basically it allows the muddy water, sediment from the muddy water to settle down and be captured in the basin and not be released into the streams. And these pictures just illustrates how much sediment really can be captured on those sediment basins. And we do have guidelines on when they should be maintained. One is the accumulated sediment must be removed once the sediment has reached 40% of the storage volume of the basin. And the other trigger for its maintenance would be when the sediment must be removed and the basin restored to an as-built prior to the final acceptance of the development. Just a couple of pictures, illustrating, how this basin maintenance, it's sometimes, a very involved task, needing the right conditions and the proper equipment. But that is how we want to leave these basins when we are done with them on a construction site. So with that, I would turn it over to Ben, and Ben would be the person that will discuss the functions and maintenance of these basins. Thank you.
All right, thanks, Jay. I am Ben Poole. I'm with Hamilton County Planning and Development, and my main role is stormwater plan review for all new developments in Hamilton County, and as well as dealing with different inspection aspects of basins once they're completed. Pull up my screen here. And so I'll start with what is a detention basin. And this kind of goes off what Che was talking about with sediment basins, and sediment basins are only during construction. And then once we get towards the end of a construction project and the land of the development has been stabilized with vegetation and grass, so there's less erosion, they will transform it into a detention basin and clean out the sediment, and that'll be its permanent use from now on. And detention basins are used to capture the runoff from a development, usually through the storm sewers, or they can be directed there from surface flow of water. And what they will do is they will have a riser here, and you can see that there, and that will have, and that's called an outlet structure, and that will have some configuration of holes and windows in it or different outlets, and that will slowly release that water that collects in the detention basin, and it will go through at the bottom of the structure there. There's a pipe that goes under the dam, and it will let the water go where it was previously flowing, usually to a small stream or creek, or sometimes to other storm sewers if it's closer to an urbanized area. And detention basins are needed because with urbanization and new developments, you go from grass and trees and bushes where a lot of water infiltrates into the ground and is used by the plants, and it is replaced roofs, sidewalks, roads, etc., where the water is running off and going to storm sewers and is flowing a lot faster. And there's also a larger volume of runoff because there's not that infiltration into the ground. And you can see here, this is a graph that kind of shows that. So this would be during a rain event, you've got time, and this is the flow rate of the runoff. And so you can see pre-developed, which would coincide with this, there's not as much flow rate and it takes a little bit longer. And then once it's urbanized and there's a lot more impervious surface and faster runoff, you get more volume of runoff, and you also have water flowing a lot faster into the streams, which causes erosion and issues like that. And also there is the issue of pollutants, whether that be trash, sediment, like Jay was talking about, oil, or say fertilizer from lawns. That's all stuff that you don't want to be getting into the waterways. And generally we'll have 3 different detention basin types and subdivisions. I'd say 90% of the basins, especially in Hamilton County and a subdivision, are going to be a dry pond detention basin. And so within a few days of a rainstorm, these by design should be totally dried out, and they will only have water during rain events or shortly after. We have retention basins, which are wet ponds, and those always have water in them, and they could be used for fishing or recreation. People can see this one has a fountain in it, so it looks better for the subdivision. And these do the same thing as a dry basin, except they store the water above that normal water surface elevation, and then after a storm, it will slowly draw down to where the water is there, and that's the permanent pool. And then we also have underground detention basins, as you can see on the right there. These are not often used in subdivisions, but there are a few with these. And this one is actually, it's an underground chamber system. And so there's gravel below and above those orange kind of arch pipes you see there. And the water will be directed into that, and it will, there's space in between the gravel to hold water and then also in those arches. And those would be discharged the same way through an outlet structure that's connected to the orange pipes there and released downstream. And so this is not the best picture of a detention basin, but you can really see all the parts of it. And I think that'll help with understanding how they work. So you can see the riprap over here, and it's out of view, but there's a pipe coming in right there. In high school, so there's one pipe bringing all the water from the storm sewer in the parking lots into the basin here, and this riprap there is to prevent erosion in the basin. And then we've got, this is the outlet structure, and you can see this gravel covered pipe here is connected down there, and that is for water quality, and that's a really slow release, and I'll get to that in a few slides here. And then you can see they've got a grate over it since it is at the school, but there's a larger window there for bigger rain events when the detention basin fills up a little more to let a little bit more water out. And then you can't see, but there's also a grate on top of that for even larger storm events to get more water in there and get it downstream. And then finally, you've got the emergency spillway, and this one is concrete. Some of them are concrete, some of them may be riprap or gravel, and then some of them may actually just be grass. But they're typically 6 inches or a foot cut down lower out of the top of the dam. And that's for if this were to get clogged or anything, or if we just had a really, really big rain event that the detention basin was not designed to handle, it directs that flood route over to somewhere where it's controlled and it's not going to cause issues for the whole dam or anything like that. This is just a kind of a closer up of some outlet structures. And this is really the primary control and what is the design for the basin, because that's what controls how fast water is let out of the basin and how much. So you can see this one, there's those small round orifice there, and then also a window kind of cut out there. And then you got the overflow window and the grate. And on this one, this is another version of that water quality pipe. So what this is that's a perforated pipe under the gravel there. And that goes all the way into the outlet structure, and the water will infiltrate through the gravel and through the pipe. And then this one, it will all drain through there unless it got high enough, and then it has the overflow window there. And so basins in Hamilton County and Ohio and really all over, they can be designed for stormwater quantity runoff control, which is going to be for flooding primarily and erosion. And these will normally let out more water faster. And then we also have water quality. And this is designed to hold water in longer, to get more sediment out and get more pollutants out before you release that water downstream of the development. And now all developments over 1 acre in Ohio are required to design for water quality. And you can see, so this is an older basin down here, and this would this is, I think, from the 1990s, and no water quality regulations existed at that time. And so you can see this is a concrete paved gutter, which would go all the way to the pipe that's bringing water into the basin. And so it really concentrates that flow and gets it out of the basin really fast with a larger orifice there at the bottom. And it's not going to do much for water quality because there's no time water to infiltrate into the ground. This also heats up runoff because of the concrete and the sun. And then this is kind of a sketch of a water quality basin with a lot of water quality features. You won't see many basins like this, but it shows a lot. And so this right here represents the pipe bringing water in. And this is called a forebay, and this is just a small area wherever water is being brought into the basin. And what this does, it fills up some, and that allows the sediment to settle out in the forebay, kind of like the sediment basin that Shay talked about. And then eventually the water it can leach through the spillway, or once it fills up, because it's a smaller forebay area, it'll go into the rest of the basin. And what this does is it first allows more sediment to get settled out of the stormwater, but also makes maintenance and cleaning the sediment out of a basin a lot easier because it's all concentrated in one area and can get a little deeper rather than having sediment covering the entire bottom surface of the detention basin. And you can see there's some other things that can be designed, such as baffles, which would just be kind of mounds in the basin to make a longer flow path for the water, to where this is a really short flow path and it's not doing much for water quality, where this would allow for more infiltration and more filtration from grass and different vegetation that may be in the basin. And then this would be the same idea with the outlet structure there and the pipe and the outfall, and this is the dam. And you can also see they've got an emergency spillway there. So here are a couple more pictures of some recent water quality basins that have been installed. This one was really recently done. You can see the vegetation still not quite established, but the pipe is bringing water in over on this side. And this is the forebay, and you can see the small forebay dam. And it's hard to tell, but it's a little lower in the middle to direct water once the forebay fills up through the middle. And then they actually have a flow path here, but this is not concrete like it used to be. This is a really just grass and a little erosion mat, so that allows water to keep infiltrating into the basin there. Then this another one, you can see the emergency spillway. It's just grass, but that long area right here is kind of lower than the rest of the dam. And this is just yet again another water quality perforated pipe outlet. So this is all connected to one long pipe under here. And so that water has to infiltrate through the gravel into the perforated pipe and then to the outlet structure and downstream. And so who is responsible for these basins? In Hamilton County, all detention basins are owned by either the property owner who owns the property where it's sitting, or an HOA if it's in the subdivision. And you can see in 2007, we changed our regulations to require an HOA to be responsible, and they're required for all new subdivisions. But prior to 2007, that was not the case, and there shouldn't be any after that, but before, and there will be some subdivisions where a detention basin will be responsible for the whole HOA, and then some where just the property owner who owns that lot would be responsible for it. And this is determined by the subdivision record plat, which is on file at the Hamilton County Recorder's Office, or probably the Recorder's Office for other counties or jurisdictions if you're not from Hamilton County. And these can also be found, and I'll talk about these in a little bit, and they can be found online, or if you needed help finding them for your subdivision, you could contact my department and we could help you out with that. And so now we'll get to some common issues with detention basins. And really they all kind of build off of each other in a way, and they can be, maintenance overall can be not as big of a deal if it's more frequent minor stuff and just keeping an eye on the basin rather than letting it go for 2, 5, 10 years and then trying to fix it all at once. And so the main issues are normally overgrown vegetation in the basin and around the outlet structure, and then also trash and debris, because anything that's in somebody's yard next to, say, a drainage swale, or in the street that gets washed down into the sewers is going to end up in the detention basin. And what happens is, you can see this is a small commercial basin and there's a lot of garbage in there. And then this, you can see a lot of trees grew up in the basin. And so what happens is that debris, trash, vegetation will get into the orifices of the outlet structure and clog it up. And so that doesn't let the water drain out of the basin as it should. And it will, as the water sits there for longer, and more sediment will settle out. And then you can see some buildup. So these 3 pictures are actually all the same detention basin. This one was in 2008, and you can see this is the bottom of the basin, and that's just a pipe that's connected underground here to the outlet structure. And then you up here, there's another orifice for the larger storm. And we went out and inspected in 2019, and you can see the trees had grown up and the sediment pipe right there. And so it's all the way up to here. And a violation letter to say they needed to clean out the basin, the sediment, vegetation. And there was a misunderstanding. You could see they came in and they did clean out all the trees and vegetation, which you can see here. But this, you can kind of see more how much sediment has built up in that basin. It's all the way up to this second orifice up here. So that's probably about 3 feet deep of just kind of mucky, muddy sediment that is in that basin that really needs to be cleaned out for the basin to function as it was designed, because when there's all that sediment in it, it doesn't have the required volume for stormwater detention, and it also is not releasing it at the same rates how it was designed, because this orifice doesn't work at all, and it all just goes straight to this higher orifice here. And now this is a good example, I think, because it may have been something as simple, say in 2010, that something got clogged up in here. And if there would have been frequent inspections, they may have noticed that and been able to clean it out, and it would look in a lot better shape, more like this. But as that clogged up, one thing leads to another, and there's sediment buildup and more vegetation, and it can get kind of nasty to where, to get this excavated, I mean, it's going to be a very expensive repair, because you're going to need to pay someone to come in and not only get heavy equipment in there to dredge out the sediment, but also pay to transport all that sediment off site. So this is kind of touching on what I had said earlier, that frequent inspections and routine maintenance can prevent the more expensive and bigger problems down the road. And this is what we typically suggest is monthly, and then after really any large rain event or storm, go inspect the outlet structure and the pipe downstream and any of them in the basin, just to make sure that nothing has washed into them or clogged it up. And then also a few times a year, and again after large storms, is just inspect for trash, debris, big tree branches, anything like that, clean it out of the basin just so it doesn't clog anything up or cause issues. And then also look for erosion and sinkholes, animal burrows, and the dam. And those can cause issues if they're not caught, and could cause eventually dam failure. And that can be, if you do see erosion where there's no grass, it's as simple as filling it in and putting some grass seed on it. Or if it does look serious, you may need to have an inspection done. And then for vegetation management, if it is a grass basin, which most of them are going to have grass, it's good to mow it a couple times a year, not let it get too out of hand, because the more vegetation, it can clog up more. But you don't want to cut it too short either, because the longer grass does provide for more filtration, and also decreases the likelihood of erosion in the basin. And then let's see, so this, I covered this, and yeah, and a big issue we see is trees and shrubs around the basin. You can see here, the basin is in pretty good shape. It's got grass, but they've really let the vegetation and trees kind of grow up around the outlet structure, which is really where you don't want it, because any of that could clog up that thing. And the next thing you know, you may have water staying in here for 1, 2, 3 days, a week, or 2 weeks, and that just leads to more issues. And then this is sediment removal. And this typically, no matter what, would need to be done every 5, 10, 15 years. And that'll depend on where the basin's located, how big of an area is draining to the basin, and how much sediment's getting in there. And so this one was a good example of a basin. I was just out there a few weeks ago, and this is in a subdivision kind of back in the woods. And so the basins that are back in the woods are also more prone to clogging because there's so many more trees, leaves, and debris back there. And this one is actually the lowest orifice in that outlet structure is actually, I think, 2.5 feet below the sediment that has covered the entire basin. And this may have been, and you can see these trees here, and it could have been one tree or something that got stuck in there. And over the last 10 or 20 years, it's filled in. And I mean, you're going to be looking at tens of thousands of dollars, if not more, to get somebody in there and actually get all the sediment out of that basin to get the detention basin so it's functioning as it's. And this is a better example of that about something with times they may be riprap rock like this. And so you can see there's like a 36-inch pipe there that's bringing water in from, there's a lot of parking up here and paved surface. It's all routed to this pipe. And so what happens is all the water will come in here and it kind of gets trapped in here for a little bit until the sediment can settle out and the water kind of filters out through into the rest of the basin, and then the outlet is over here. And so these help with sediment removal, and they also can help make maintenance easier because it really concentrates that sediment. The only downside is depending on how they're installed or designed, they can have standing water for longer periods of time, but that really depends on the design, and that can just be a nuisance with standing water there. And so this is an example of a record plat for a subdivision. And so there's all kinds of notes on here we have MSD for sanitary sewers, there's things for water, streets, mailboxes, and somewhere on there you'll find, so down here we have private drainage easement for stormwater detention retention facility. And this is going to be all the legal language of who is responsible for maintaining that basin. And then it also says what is allowed and not allowed. And typically it says, you can see no structures or structure alterations, plantings, or other materials can be placed in the easement that are going to change or obstruct any of the flow or the detention function. And so let's see, for example, this one, you can see the installations within said easement, the easement areas of each lot, and all improvements within said easements are to be maintained continuously by the Fort Scott Homeowners Association. This was a more recent one. So this one is dedicated to the HOA, and so they're responsible for maintaining it as a whole. And you can see this is also more stormwater stuff right here that's highlighted. This is the stormwater detention table, and this should be on any record plat, and that will have the design volume and release rates that were approved with the subdivision for the basin there, and also the total volume of the basin, which it should have. And then this is the maintenance schedule, the responsibility for a detention basin. And so that has really some of those same points that I talked about a few slides ago. And then this is a facility ownership and maintenance agreement that we require to be signed by the HOA before it's submitted to us for approval. And these two sections, the maintenance and maintenance agreement, we've really just started pushing those since water quality basins. So this may not be included on some older subdivision record plats, but they should definitely have this, which will say who is responsible for maintenance and also the numbers for the basin itself. And then additionally, at the end of each project, just getting ahead of myself. This is the second page of that same record plat that was on the previous slide. And so this shows, you can see all the lot lines, the street here, and you see the private drainage easement. So this line right here is where the detention basin is, and that's where that easement for the basin is. And then you also have a private drainage and storm sewer easement. So this right here would be where you have the outlet structure, the pipe going under the dam, and then the head wall here. So you have an easement covering all of that. And then you can also use this to see, I mean, this is a sanitary sewer easement here. And then on the side of each lot line in this subdivision, there's 10-foot private drainage easements, and that's just to help get water for flood routing or just to make sure that water's flowing in between houses where it needs to go and not into people's houses, garages, driveways, etc. And then lastly, you can see here there's a 15-foot public storm sewer and private drainage easement, and that's this line here. It turns into the basin. And so this would be the low point of the street, and there would be a catch basin, and there's a public storm sewer here since it's draining the road, and that would either be maintained by the township or my department, Hamilton County Planning and Development. And so really, if you're wondering if there's any, say, storm sewers or drainage swales on your property, they should have an easement from when the subdivision was designed, and these would all be shown on the record plat for your subdivision. And then lastly, for each subdivision and detention basin, before we accept it, we require an as-built of any public storm sewer and any detention basin. And so this is, you can see the contours, and these were from a survey after the construction was done, after the sediment basin skimmer was removed and the sediment cleaned out. So you can see the two pipes that are bringing water in from the development. This is a riprap, and then the outlet structure is right here. And this is a head wall and drain pipe there. And so, and then also you see the outlet structure detail, so it shows that you've got, let's see, a 12-inch orifice at the bottom. And so you would be able to go out and look at the outlet structure, and you should see that. And then a few feet above it, a 15-inch orifice. And those are what were approved for the detention basin design when the subdivision was designed. And so any basin within likely the last 20 years, we would have an as-built on file. And if not, we would be able to find some plans, so we would at least know what was approved with the design of the subdivision. And so this would be useful if you ever needed maintenance done or just to check and make sure everything's all right. And some additional resources is, if you go to Claremont County, and you can Google this, they have a really thorough kind of manual on detention basin maintenance. It goes over a lot of the basics of what I just talked about, and also provides kind of a schedule of what maintenance should be done. And I think they even have a maintenance checklist, which will help HOAs kind of have that on file and log who's doing them and know when you've done inspections and what was wrong and what to watch for. Ohio EPA has a similar manual on their website for maintaining stormwater control measures, which is generally going to be detention and retention basins. You can go to the Hamilton County Recorder's website to find record plats for your subdivision with that information. And then also you can contact our department or on Hamilton County's website, where you can find all our phone numbers and emails. And this is our general line number right here. And you could call us with basic questions on the detention basins, but even if they're specific to your subdivision, because we can look at that in-house, see how it was designed, and then also we can provide you plans or as-built or record plats or any other information that we may have on file for your subdivision or detention basin. And that's all I've got. So I think I will pass it on to Adam, and he can go over some retrofit stuff.
Alrighty, thank you, Ben. Before Adam gets started, I just want to remind everybody that if you have questions, you can enter those in the Q&A feature at the bottom, and we will answer those after Adam is finished. Thanks.
Great, thank you. So my name's Adam Lehman. I run a stream conservation program here at the Hamilton County Soil and Water Conservation District. And the mission of that program is basically just to improve the health of the streams in our communities. And these stormwater detention, retention basins represent a huge opportunity for improving the health of the streams in our communities and in your neighborhood. So I want to talk about that a little bit. But first, I want to kind of set the context for this, right? So what do I mean by stream health, and why should you care? So I always like to start this with kind of a global context and then moving local, right? So this information is from the World Wildlife Funds. Every 2 years, they publish their Living Planet Index. And this is showing basic trends in population abundance for freshwater animals worldwide, right? This data set is huge. It's got good kind of geographic distribution. And it's basically showing that there's an 83% decline has been seen in freshwater animal population abundance since 1970. This is a striking statistic to me, right? Because we're not talking about since, colonization of North America. We're not talking about the dawn of the Industrial Revolution. This is the last 50 years, 83% decline. So that's, I would hope that's offensive to the sensibilities of many people. Moving locally, the information we have to glean from this is based on the Ohio Department of Natural Resources. That they create lists of species that are extinct, extirpated, endangered, threatened, and species of concern for each county. So basically, the species that are gone and in not great shape. And so this is the list for Hamilton County. And if you start digging into it and really looking at what the species are that are included on that, you see that there's 77% of them are dependent on stream and wetland habitats. So the point here is that aquatic wildlife is really taking, a large portion of the brunt of the decline in global and local biodiversity. So with this in mind, thinking locally, the question becomes, well, what exactly is it that's the problem here in Hamilton County where we got some power to do something about? And we're lucky here to have this wealth of information on the condition of our streams as a result of the Metropolitan Sewer District's consent decree. They commissioned the Midwest Biodiversity Institute to do these very detailed studies of our streams throughout the county. And so long story short, there are several things that are impairing our streams. But as you really start to dig into the data, it becomes clear that there is one item that is the most widespread, kind of ubiquitous problem. And it also is the most foundational problem, meaning that, even if you addressed all the other problems, you're not going to make much progress in restoring the biological condition of these streams unless you address this one foundational issue first. And that's altered hydrology, right? So we have developed this area. We are in an urban county. We have covered the surface with impervious surfaces like roads and parking lots and buildings and all these things. And there's two kind of faces to this same coin, right? There is that when you don't allow the water to soak into the soil because it's covered in asphalt, then you don't get that water soaking in and recharging the groundwater. And the groundwater is really what provides the flow, the water to these streams, particularly the smaller headwater streams in between rain events. And so you get streams drying up. There's streams like this one. This stream has a drainage area of probably 3 miles, right? It's a pretty large stream, and it frankly should be supporting perennial pools that support fish, right? And when we see something like this, it's not a degradation of aquatic habitat, it's a complete loss of aquatic habitat. And so, as I mentioned, this particular side of the hydrologic alteration impact is particularly acute with headwater streams. So streams that are say, 20 square mile drainage areas to 1 square mile drainage areas. And the thing about that is that those represent the vast majority of the stream miles here in the county, more than 85%, right? And so this really does represent a huge loss of available aquatic habitat locally. Now, the other side of the coin is that we have this increase in the frequency of erosive flows, right? The water is hitting the pavement, it's going straight into the sewer. We've got these hydraulically efficient pipes and ditches delivering them straight to the stream. And the result of that is that, you know, pretty much every time we get a decent rain, there is major, you know, erosive flows in the stream. And so this has an impact on the biology directly, right? So these are erosive features, and the organisms that evolved in them evolved to handle these types of disturbance, you know, say once, twice, 3 times a year. But when it starts happening 20 times a year, that's ecologically significant. And we're finding that it greatly limits the organisms that can survive in these systems. It also destroys habitat, and it destabilizes the channel, and that kind of beyond the ecological perspective creates a lot of damage to the public and private property, right? So people losing large chunks of their backyard, losing fences. We've got this picture here on the bottom where this stream was eroding into someone's leach field. You know, that's like a $25,000 repair right there. There's really sad situations in the county where people's homes are being jeopardized. There's a multi-family unit, maybe 10, 12 unit building that has just been evacuated recently in Anderson Township. Major economic ramifications there. And it also creates societal problems from impacts to roads, like you can see here, and other utilities as well. So where do detention basin retrofits come in? The detention basin retrofits represent a huge potential from, you know, efficiency of, you know, how impactful a project can be for the acreage that you're working on and for the dollars that you have to spend on it. Because we have these basins that were designed so that large swaths of impervious surface are being delivered to them. And so, as been described, you know, these things were originally created as flood mitigation measures, right? To reduce the flooding downstream. And recently, they've had water quality components that have been built into them. But what they're not designed to do at all is to reduce the erosivity of flows coming out of them. But the shame of the matter is they could really easily. It wouldn't necessarily require larger basins. It wouldn't necessarily require, you know, a huge amount of extra design work beyond what's already being done. But the fact of the matter is it's just not currently required by local regulations. And so that's something that, you know, that may change in the future, may not, but either way, in this historically developed county, we have a huge amount of legacy detention basins that can be retrofit relatively simply and easily. So what do I mean by retrofitting? In the most simple sense, you just, you know, can reduce the size of the low flow orifice, you know, the bottom one, perhaps the bottom and the second one up, so that these smaller events are detained longer and released at non-erosive rates. Now, you can do this with maintaining the ability of these basins to hold larger flood events by simply increasing the size of orifices higher up. And so a point to be made here is that, you know, we're not talking about trying to detain these huge events, because we're talking about trying to reduce the frequency of erosive events. And so, you know, we're perhaps events that are less than a 1-year return interval event, you know, maybe up to a 2-year return interval event, you know, these things can be detained and still drained within, you know, 24 hours, maybe a little bit more. And it wouldn't really change the functionality of the basin very much. And so what might that look like? In this most basic example here, so we've got the before image where we've got this low flow orifice down here that's kind of buried. Maybe Ben would say that we we've got some maintenance issues here. And so what did they do here? In this situation, they've kind of incorporated these new water quality features here, where they have the long perforated pipe and it's got gravel on it, and that has all these great water quality features. And I want to stress here that that's not required, right? If your basin was created before these new regulations were in place and you're open to retrofitting it, we're not here to add red tape and make this hard, right? If you want to make it better, we're going to take what we can get. And we're not going to necessarily require retroactive regulations to be adhered to on this. So another thing to look at here, in its most simple form, it could look something like this. We see this square where it used to be the second orifice. And what that is, it's a steel plate, right? So they just basically bolted a steel plate over the old hole with a smaller hole on it. And so just something that simple can make huge impacts on the downstream health of the streams in your neighborhood. So this is what a simple retrofit looks like. But if your community is interested in taking the next step, we can go much further on this and turn this into a habitat restoration project. So perhaps the people in your community might value having a little nature preserve in the middle of your neighborhood. With maybe you could get a walking trail around it, and we can put features and vegetation inside of it that will attract birds and pollinator species and things like that. So this is kind of examples of taking it to the next step. And so the message that I'm here to convey is that we are interested in working with HOAs who are interested in improving the quality of the environment in their neighborhood. And so if you have any interest in this, whether it be big or small project, just give me a call and we can talk about it. No pressure. So here's my contact information. One more thing I want to point out before we move on to the question period here is I got Sustainable Streams emblem down here, and I'm crediting them here because they were kind enough to provide me with a lot of the diagrams and images that I had in this presentation. So they are a local company that does a lot of these detention basin retrofit projects. With that, I'll let Sarah regain control for the next phase.
All right, thank you, Adam. So I guess Ben and Che, if you would like to unmute yourself and show your video, we do have a question. If any of the attendees have a question, now is your time to get those in the question and answer section. But we do have one. Does planning and development have the ability to show the distribution and volume of detention basins in Hamilton County? If so, could we compute the water storage after 0.5, 1, 2, 3 inches of rainfall with older designed basins and retrofitted basins?
So the first part where it asks about the distribution and volume of detention basins in the county, if you're meaning like overall across the whole county and all the basins together, we do have in our mapping system a inventory of every single basin and water quality basin that's there. And assuming we have that information, there's some of the older basins that we may not have that data for, but we do have the volumes of everything. And then about computing the water storage after rainfalls, that could be done. It would be done by looking at the drainage area that drains to that detention basin and how much area of impervious surface and how steep the slopes are and things like that.
All right, thank you, Ben. Okay, we have one more. Let's see. How much larger are detention basins now that they must reduce solids by 75% and previously with 50% reductions of NTUs?
So in Hamilton County, the basins are not any larger with the new water quality regulations. We do not require, so the way they're designed is we have a required storage by our county regulations that does not handle water quality. And so that's only for the water quantity control to control erosion. And so that's going to be designed for up to 100-year storms. So those are the larger volumes. And the water quality volume, which is to reduce the total suspended solids and stuff like that, is usually a lot smaller because that's only designed to handle now a 0.9-inch rainfall event for that drainage area. And we allow that water quality volume that's smaller to be incorporated into our water quantity volume from our other regulations.
Great, thanks again, Ben. All right, if your HOA has many different retention / runoff basins, how are those best assessed? This HOA is 30+ years old, so they assume individual ownership. How best to proceed initially?
That's a hard one to answer, assuming you're talking about who's going to be responsible for any maintenance or repairs on it. So we have changed our regulations, and now they say that the HOA is responsible for basins, but even on those older ones, as I talked about on the record plat, it says very clearly that it's to be maintained by the owner of that lot. It's really going to come down to a case-by-case basis. Ideally, the HOA would work together because these basins do serve the entire development and whole subdivision, rather than the one person that owns the lot with the basin. But I can't say who would be responsible if the HOA was going to push back against that and it would come down to that property owner. That would really be more of a question of law that I'm not qualified to answer.
All right, thank you. So before I'll give everybody a couple more minutes to get in another question if they'd like a follow-up. But our door prize winner is Chelsea Obrepski. So Chelsea, if you'll just let us know you're here, in the question and answer section, you can say, "Hey, I'm here." You can put your hand, raise your hand, and then I will reach out to you within the next week to get you your door prize. Right, Chelsea is here. Thank you, Chelsea. All right. So no more questions have come through. So I would like to thank Adam, Che, and Ben for being here with us tonight. All the attendees, we hope you are able to join us again next Tuesday at 7 o'clock. We will be discussing rain barrels and rain barrels and composting, sorry. So I hope everybody has a great evening and we'll see you next Tuesday.